This video is about percentage yield and calculations associated with it. So our first question here is yield. Yield is what's produced, so a field with yield crops. In chemistry, it's what's produced in a chemical reaction. So we're interested in the quantity of a product produced in a chemical reaction. So reactions have reactants and products, and so the yield is the amount of product produced. Now we're interested in this in chemistry because in industrial chemistry we're interested in turning reactants, raw materials if you like, into useful products that we can make into other things or sell or use in the human race can use. It's unlikely in a chemical reaction you get 100% yield, that all the reactant turns into products, so there will be waste produced. So what we're interested in chemistry is being as efficient as we can, turning as much of those very valuable raw materials into products as possible and into minimising waste. And that's why we're interested in percentage yield. So, why is it rare to have 100% of the reactants turn into expected products? Well, there's three reasons for this, and you need to learn them for the exam. They're very important. The first one is unreacted reactants. Unreacted reactants. So, some of the reactants do not get into that chemical reaction. We often do this with magnesium ribbon in school labs and turn it into magnesium oxide, and we can calculate the percentage yield. Now, quite often when you look at the magnesium ribbon that's burned, there's a tiny bit of magnesium ribbon at the end that just hasn't reacted. Maybe it's been in the tongs as you're holding it in a Bunsen flame, or just didn't react in the crucible or whatever else. So unreacted reactants. Next one, lost product or practical losses. Maybe you spill it or something. Lost product. So, think back to that magnesium ribbon burning in the crucible to make magnesium oxide. Often you see white smoke appearing at the top. That's lost product. That's magnesium oxide that's being lost from the crucible. So lost product or practical losses. And the third one is unwanted or competing side reactions. Okay. A nice side reaction you need to know about in chemistry for GCSE is in the car engine. Now, the car engine burns petrol with oxygen from the air to make the carbon dioxide and water that comes out of the exhaust pipe, and it yields the energy to make the car go. But a competing reaction, which isn't useful in the car engine, is the nitrogen in the air. And air is nitrogen and oxygen. The car engine sucks in air, so the nitrogen and oxygen also combine to make nitrous oxides that can go out of the exhaust and into the clouds and make nitric acid in the form of acid rain. So there's a competing side reaction in the car engine. So sometimes these competing side reactions stop us getting 100% yield. So it's useful if we can calculate how efficient the reaction is, and we do this with a percentage yield calculation. And like all percentages in chemistry, it's really quite straightforward once you know how. I always think about calculating percentages as if you're doing a test. So if test's out of 60 and you get 45 out of 60, you would write it like that when you 45 out of 60. And that's how you write it on the front of your test paper. To turn it into percentage, you simply multiply it by 100. It's 45 divided by 60 multiplied by 100. So it's what you get, divided by the theoretical maximum, tests out of 60, and then you multiply it by 100. So in chemical reactions, you weigh what you get at the end. That's the 45. That's the actual yield, and you divide it by the total. So you can do a calculating quantities calculation to work out the absolute theoretical maximum. And so you divide the two and then multiply by 100. Okay, so if the expected yield is 10 grams, the actual yield is 5 grams, that's 5 out of 10 this chemical reaction got. 5 out of 10. If we actually got 5, it's theoretically possible to get 10, so it's 5 divided by 10 multiplied by 100. Now, next page is lots of these calculations. They're quite straightforward. I'm not going to do them all by any means in this video. You can do them on your own. Let's just do number 5 together, just so you've got an idea. Long, wordy question. This is very similar to an exam question in an Excel paper from years ago. But it struck me at the time, it was so wordy, lots of people got it wrong because it was so wordy they couldn't get the important information. So let's look at this one. It is possible to turn ethene into ethanol by reacting it with steam. This is done in factories on an industrial scale. One such factory takes 2 tonnes of ethene and produces 2.96 tonnes of ethanol. Chemists at the factory have calculated that 2 tonnes of ethene should produce 3.28 tonnes of ethanol. What is the percentage yield of this calculation? So percentage yield, so it's the actual yield. Come back here. It's the actual yield divided by a theoretical multiplied by 100. So let's quickly write that formula down. I'm a big fan of writing these formula downs in all these practical questions, because the more you write them down, the more you drill yourself to get the whole thing right. Remember, if you can't remember the formula exams, you can't do the question. So write it down when practicing, and it just gets it a little bit further into your head. Multiply by 100. So we need to find the actual yield and the theoretical yield. Now there's too much information in this question, and this bit here, for example. One such factory takes 2 tonnes of ethene. Doesn't matter how much ethene we take. We could use that to do a calculating quantities calculation, so work out the theoretical yield, but that's done for us in this question. Chemists at the factory have calculated that 2 tonnes of ethene produces 3.28 tonnes of ethanol. So this 2 tonnes is just there as a distractor. We don't need it. Not needed for this question at all. So one such factory takes ethene and produces 2.96 tonnes of ethanol. So that factory produces 2.96 tonnes of ethanol. That's the actual yield. So 2.96, that's the actual yield. The chemists have calculated the theoretical yield at 3.28 tonnes. 3.28, so that's the theoretical yield. So there's our theoretical yield, there's our actual yield. Just have to get them out of the question. It's actually quite hard to do that. Multiplied by 100. The good news is the more you practice questions like this, the better you get at it. So if you can't spot it straight away, don't panic. Just get better with practice. So let's put those numbers into a calculator. Okay, so we've got 2.96 divided by 3.28 multiplied by 100. Stick it all in like that, press equals. And we've got 90.24390. Now, just report the same number of decimal places as are in the question. 2 decimal places in the question. So we're going to report 90.24, check next number, it's a 3, it's less than a 5, so that's going to stay at a 4. 90.24. 90.24%. It's quite an efficient process, that one. Chemists at that factory are probably quite happy. And that's our answer.